Hi Ubaid, hello Yogita, hi Abhishek, hi Ankit, hello Prachi. Yes, how are you guys? How's your preparation going on? I hope I'm visible and audible to everybody here. Yes, welcome to all of you guys and a great evening from my side. And for all the people for them, I am a new face. So let me just give my brief introduction to all of you. So guys, my name is Deepak and I'm a BTech in electrical and electronics. Okay, and I'll be taking up this session for you. Okay, so now I'm going to start of the session, guys. So today we are going to discuss about the human eye and the colorful world. So I know it's like something related to a bit biological as well as a bit theoretical chapter, but it is obviously an important one as the board perspective. So I'm going to take it this one. So let's just start off the slides, guys. So guys, now we'll talk about the weightage. So total the physics portion is comprises of 28 marks. Okay, in that we do have three units. In that we do have natural phenomena where the light refraction and reflection is coming, and the human eye and the colorful world is a part of this. Okay, so we are going to discuss this one today. Okay, and the rest one it comprises of almost 12 marks, guys, so we cannot leave it and we have to put lot of concentration in this portion as well. So rest is electricity, magnetic effects of current, and sources of energy. And another thing, sources of energy, you know that this is again a scoring chapter as well, where you just need to uh, there are a lot of theoretical part in this, so you lot of the things you just need to mug it up actually. Okay, and the rest of the things in this portion and this portion, basically the numerical portion generally come from here. Okay, so let's just discuss about the human eye and the colorful world. Let's just focus on the mind map, guys. So here, if you see the chapter overview, so the entire things are revolving around the human eye, because human eye is something that we are going to discuss here, where we do have ciliary muscles, optic nerve, eye lenses, cornea, pupil, iris, and retina. So in 5 mark question, it may come that what is the draw the draw the label diagram of a human eye, and you have to uh, uh, like uh, briefly explain all the functions of these parts of the human eye, where the ciliary muscles, what are the ciliary muscles, what is optic nerve, eye lenses, cornea. So ciliary muscles, everybody, anybody here who can tell me what ciliary muscles functions are? So ciliary muscles function is to adjust the focal length, because it is going to change the shape of the lens. So if the shape of the lens is going to change, then its radius of curvature is going to change. And according to that, we do have a formula, guys. You know that. Let me just tell you that radius of curvature is dependent like in this way, right? So according to this relation, the focal length of the eye lens is going to change. Okay, yes, it adjusts the focal length. If we talk about the optic nerve is the one which is sending the electrical signals to the brain, isn't it? Because we do have a inverted image. If I just draw the, just a moment, guys, I'm a bit bad in the drawing, I'm really sorry for that. Okay, so what is happening here, we do have a lens in between. Okay, and the rays are coming, and this lens is nothing, we call this one as a crystalline lens. Crystalline lens. Okay, this we call it as crystalline lens, and these rays are going to merge at the retina, where the image is being formed. So you know that this is nothing but a convex lens, so image will be formed as inverted, and this image is going to be very very small. So the this optic nerve, what it does, it is going to send the electrical signal to the brain, and again it is flipping it. flipping this image. So that's why all these images are seen as erect instead of inverted. Okay, so this is the function of the optic nerve. Now we talk about the eye lens. You know that it is going to converge the rays that is coming from the different that is coming from different distances. And we'll talk about the cornea. Cornea is nothing, is a transparent layer that is going to uh, protect the eye, protect the eyeball. Okay, pupil, again the function of the pupil is to adjust the light, okay, the amount of light that is being entered in the eye. So that is going to control by the pupil. And if we talk about the iris, it is just controlling the size of the pupil. Okay, and retina is the place where the image is being formed. But a crystalline lens is made up of some jelly material. Okay, crystalline lens is not the actual lens, it's not made up of the glass. Okay, it is just some jelly kind of structure from it is being made. Fine. So apart from this human eye, we do have other things like the power of accommodation. Power of accommodation is being happened because of the ciliary muscles, if you know that, right? Because without the adjustment of the focal length, we cannot I cannot adjust its focal length and do the power of accommodation, isn't it? Okay, let's talk about the other part of the chapter, and these are very very important, guys, as far as the theoretical perspective. If you see the atmospheric refraction, generally in this portion lot of questions are coming, like why do the stars twinkle, or why there is a 2 minutes of delay and 2 minutes of early rise in the sun. Okay, so yes, so these are kind of questions are coming, may come. Okay, if we refraction through the prism, another thing like the dispersion, right, that is also being covered in this chapter. And the scattering of the light like the Tyndall effect, or you must have seen why the dangerous signals are made up of red and all that, right? So these kind of questions may come in the exams. Okay, did you get it, guys? And yes, so dispersion of the light by the triangular prism. And guys, in the refraction through the prism, what all things are coming, we will be seeing the angle of deviation. Okay, we will be seeing the angle of deviation in this. Why we do have the dispersion in the case of the prism only? Because all the colors are feeling the different refractive index of a single prism. And what is happening, as you can see, the angle of deviation is dependent on mu of the, just a moment, is dependent on the refractive index of the prism. So what happens is all these colors, if I just make this figure for you, just a moment, let me just elaborate a bit. Okay, so I'm just sketching up a prism here. So what is happening, if there is a white light is going here, what is happening, if there's a white light, it is what is happening, it is going to disperse in seven different colors. Okay, so I'm not going to make all of them, I'm just giving an example here. So what I want to tell you here, that the angle of deviation in the case of the red probably would be different in the angle of deviation with the in the case of the violet, right? So that's why the rays are getting dispersed. Okay, what is the difference between refraction of the light in the prism and the rectangular glass slab? In the case of the prism, what is happening? The light is going to disperse in seven colors. It is splitting up in the seven colors. But in the case of the glass prism, it is again coming with a single white light. This is the difference between the glass slab and the prism. Okay, Navina? Okay. Okay, so let's just talk about. Okay, this is the dispersion of the light. And if we talk about the defects, right, these are very important, guys. So in the 5 marks it may come, let me tell you how the questions are being made. They will ask you in the examination, in the exam paper, they will ask you these some functions of the eye, or probably they will ask you about the functioning of the eye, these parts. Okay, or probably ask you to make the diagram of the eye. Okay, and they will ask you some of the defects: myopia, hypermetropia, presbyopia, or cataract, and their causes, or like how to correct them. Okay, these kind of questions may come in the exam. So if we talk about the myopia, is something that people cannot see the distant objects, right? We call this one as nearsightedness, or you can call this defect as short-sightedness as well. Okay, if we talk about the hypermetropia, hypermetropia is something is a defect where people cannot see the nearby objects, and it can be corrected by the help of the convex lens, and we call this defect as farsightedness as well. Okay, and if you talk about the cataract, cataract is something that a milky layer will be inserted between the cornea and the eye lens. Okay, so what happens is it will bring the opacity, it will bring the opacity, and what happens, it cannot be rectified with the help of a glass. You cannot just wear the specs and you can get rid of. No, you have to go for the operation for that. Okay, yes, I'm not ignoring, guys, I'm not ignoring, I'm just telling you the important things out of this chapter. Okay, and if you talk about the presbyopia is something, is a defect where it is happening in generally in the old age, where the ciliary muscles, they become very weak, and they cannot adjust the focal length of the eye lens. That's why the power of accommodation is not proper in that case. Okay, this is these are the four defects, and on this the questions may come, guys. So these are the important part of the chapter, you have to focus on this. Okay, now if we talk about, okay, important questions based on the theoretical. Human eye and its various parts, I have already told you guys, right? Human eye and the various parts, already told you about this. Defects of vision and their correction, right? In the case like myopia, in the case of the myopia, how can you correct the defect? By the help of the concave lens, right? Dispersion of the light, in this the angle of deviation is important. Angle of deviation is important. Okay, and atmospheric refraction, you know that atmospheric refraction, like twinkling of the stars, or 2 minutes of delay of this sunrise and the sunset, and scattering of the light, again the Tyndall effect. And why do the danger signals are made up of red? Okay, and why do the sky color of the sky is blue? Okay, so these questions may come from these topics. Okay, so now if we talk about the practical skill, if you see this chapter as a practical perspective, where you can see some practical experimental based questions may come also. So this question was asked in CBSE itself, and it was of 2 marks. Tracing the path of the rays of the light through a glass prism. Actually, it has to be a rectangular glass prism. Rectangular. Okay, so what you have to do is, suppose you have a glass slab in front of you. Okay, I cannot make in this way, I have to take this one. Okay, so what you can do, you have to sketch up a normal here. Okay, and suppose there is a light is coming, there's a light coming here. Okay, and it is going to refract like in this way, and again, as it is passing through the as it is making some angle with the normal. Just a moment, guys. Okay, and again, as it is moving from denser to rarer, so it is moving away from the normal, right? It is moving away from the normal. So let's just, this is going to be the incident ray, this is going to be the incidence angle, this is going to be the refractive angle. And as you know that these are going to be same, because these are the vertically opposite angles, these are two parallel lines, right? And again, this is going to be the emergent angle, this is the emergence ray. So what happens is, here the angle of incidence is equals to angle of emergence. So guys, what the experiment is based on, what you have to do is, you have to just fix up 2 pins here. Okay, you have to fix up 2 pins here, and you have to see the pins on the other side, and according to that you have to just fix up 2 other pins as well. So then you can measure the angle of incidence and angle of emergence, and you can see that angle of incidence is going to be equals to angle of emergence here. Okay, so this is how the experiment is being conducted, and this is the experimental based question here. Now you can answer this one. The student, a student is unable to see clearly the words written on the blackboard placed at a distance of approximately 3 meters from him. Name the defect of the vision of the boy. Name the defect of the vision the boy is suffering from. State the possible causes of this defect and explain the method of correcting it. So can you tell me the defect name, guys? Absolutely right. So Shreyas and Navina, these people given exactly the right answer. So this guy is suffering from myopia because he won't be able to see the far objects, or you can say distant objects, or you can write it as short sightedness. Okay, and second thing is distance approximately 3 meters. Can you calculate the power of the lens that he is going to wear? Meanwhile, I'll tell you how to state the possible reasons why it is being happened because of the eyeball elongation. You know what happens if the eyeball is going to elongate? So in this case, what happens is if the eyeball is going to elongate a bit, let's suppose like in this way, okay? So what happens is the rays of the light is going to focus before the retina, okay? Because of some reason, if the eyeball is being elongated, what happens is these rays are going to focus before the retina. Before the retina, they are being focused, okay? So this may be the reason. And second one is the shortening of the focal length of eye lens. If the eye lens focal length is going to be shortened, so what happens? Again, they are going to focus before the retina. Okay, so these are the possible reasons why the myopia is being happened. Okay, and yes, which is the lens that is going to correct? Again, we have to use the concave lens. We have to use a concave lens, and its power is going to in negative. Can you tell me what would be the power for this particular one? That is going to be minus 1 by 3 meters, because the focal length is going to be 3. Okay, and now why do the stars twinkle? This was also asked in one of the CBSE, and it has been taken from some sample paper actually. So why do the star twinkle, guys? Anybody here? Shubham? Anybody? Karishma? Shreyas? Atmospheric refraction. Absolutely right, guys. Atmospheric refraction. You know what happens is, as you know that Earth in the atmosphere, what has happened? The the layers of the Earth. Let me just tell you here. Suppose this is going to be, this is the Earth, guys. Okay. So these layers are, sorry, these are the atmospheric layers. Okay, these are the atmospheric layer. A person who is standing here, what happens is, as the star's light are coming, suppose this is going to be the star, so it is coming like in this way. Okay, just a moment. It is coming like in this way. Okay, so what is happening? As the light is coming from rarer to denser, so it is going to bend towards the normal. again bend towards the normal, again bend towards the normal. A person who is standing here, he will be seeing the star position somewhere here. I'm sorry guys, I'm not able to make it properly. Somewhere here. So this is the actual position, or I'm writing it as true position. This is going to be the apparent position. So what happens is, this is what we see, and these layers refractive index is going to change throughout the day, throughout the night. So we see the apparent position of the star, okay, and that is going to change throughout the day, throughout the night. So it appears to be twinkle to us, okay. It appears to twinkle to us, and this is the reason I have written it here as well, so you can answer in this way. Okay guys, so this is the one. These are the questions. They okay, when to put negative sign in the numerical, guys. Actually, in the case of this one, if you are taking the distance opposite to the incident ray, then you have to take the distance in the negative. Okay, okay. I don't know your real name, dream thinkers. Okay, fine. So describe an activity to show the colors of the white light displayed by a glass prism can be recombined, get white light by another glass prism. So guys, am I visible and audible to everyone here? Okay, so what is happening, if you see the two glass prism, guys, if you take two glass prism, so one, suppose I'm going to take it up in this way, and another I have to take it in the opposite sense, right? So this is going to be like in this way. Okay, so if a white light is coming and it is going to spread into it is going to disperse into 7 colors, again it is going to come out as, again it is coming out as, just a moment, it is coming out as a white light. Okay, this is the dispersion, or you can say splitting of light into 7 colors. Okay, and what is happening here, this prism ABC, or you can say this one as PQR. So this prism is giving the angle of deviation as plus delta, and this prism is going to give the angle of deviation as minus delta. So what is happening, once you recombine these two, it is just canceling these two angle of deviation. That's why you're getting a white light. This is, if you combine these two prisms, you are getting a glass slab, nothing but a rhombus kind of glass slab, isn't it? So this is what happens in the case of the glass slab. Okay, so you have to, this question was asked in CBSE 2016. Okay, now, yes guys, there are some useful tricks and tips. So remember the functioning and labeling of all the parts of the human eye, right? As this chapter obviously comprised most of the theoretical parts, so learning the not the definition properly, the explanation, you can say the explanation here, learning the explanation of all the natural phenomena will be handy. Okay, and take care of the object's distance while solving the numerical based on the defect of vision. Probably all the defect of vision we have already talked about, right? So you have to probably some numericals may come, like what would be the power of the lens to correct the myopic eye, what would be the power of the lens to correct the hypermetropic eye, right? So these are the questions may come. Oh, okay. And obviously, please practice all the diagrams and whatever it is given in the chapter before going to the exam. Okay. So, guys, these are the important tricks and the tips, and that's all from my side, guys. And for the more information, you can just browse this link and get more information. And all the very best from my side, guys, for your exams. Do prepare hard. Okay, and I know everybody will be going to be giving their best. Okay, And thank you so much, guys, for attending the session. And for more details, just check this link. Okay. Thank you so much for attending it. Bye bye. Thank you so much. Take care and all the very best.